Thanks so much to Andrew and Matt for having me at such short notice. This was actually organised a couple of hours ago to be here. So my name's Joshua Young. My name's Joshua Young. I'm not from around here, as you can probably tell from my accent. I'm from Australia. I've had this opportunity to come on a tour of the US with a program sponsored by KPMG called Elevate 61 and an amazing web TV show about startups called That Startup Show. If you go to thatstartupshow.tv, you'll see it. This is my startup. It's called Auug. You can find more information about it here. So essentially my journey started, I was living in Germany doing something completely different. I was actually doing a PhD in neuroscience. I didn't expect to be where I am now doing this while I was doing that. But while I was there, I was exposed to a lot of electronic music. And while I found the sounds that people were making very interesting, I found the way they were making those sounds very boring. I thought the performances were very obscure and hard to understand. So I wanted to give these performers a more physical and intuitive way of controlling their sounds and interacting with the digital devices and the digital software that they have. So ultimately what I came up with after a lot of iterations was actually trying to implement an idea around mobile phones. So this is essentially a hardware and software solution to create a motion-based controller. So I'm going to have to start speaking with my normal voice. No, it's okay. I will just pretend that I'm a crocodile wrestler or something. Is that loud enough? Can you hear me at the back? I'll take that as a yes. So, here's an example. Hopefully this is loud enough for you. I've got a bit of sound. Try and pump that up a bit. So, right now, I usually do this wirelessly, but because of the impromptu nature of this, I'm just going to do it with cable. So right now we're sending data to software on the laptop, and I'm controlling a variety of sounds. The first sound is a sound, something like a violin. So like with a violin, if you were just to touch the fretboard without actually moving the bow, you might hear a sound a bit like this, or not. Something a bit like that. So you actually have to move to make sound. And we can use motion to change things like octave. Or to modulate a single note. Or to change the speed at which we transition between notes. Or to switch to a different instrument. Or to trigger notes. Or to play more harmonically. So to help people sort of get a feel that this information is not purely musical, that it can really be used for anything, I like to try and show an example of something more animated. So what have we got here? Okay, so, yeah. So right now we have this animation that's essentially responding to motion, much like the violin sound is. So I'll try and play you a little bit of music now to give you a bit of a taste, and this will basically be the end of the demo. Oops. Well, that's very soft. I'm going to start again. Well, that's so soft. I'm going to start one more time, folks. I'm not used to these cables. So thanks again to Matt and Andrew and Hardwired NYC for having me at such short notice. If you have any suggestions that you'd like to tell me, if you have any questions, please come up and talk afterwards. Thanks for your time.
Sorry. Can you tell us just in a second how that works, like how, just at a high level?
Sure. So essentially, the physical part is turning it into a practical human-computer interface. So we're essentially freeing the hand from having to grasp the device, and this increases the dexterity with which you can operate the touchscreen. You also have the tactile overlay, which is very important for actually constantly orienting your fingers as to where they are. And the app part is essentially just taking data from the existing motion sensors on your mobile device. And then we're translating that into some kind of musical information and then passing that on to the laptop. But of course, you can also pass that on to other apps on the same phone. So you could use your mobile device as a synthesis device. And while at the moment we focus very closely on the needs of professional musicians, the ambition is essentially for all possible human-computer interaction. So we're now taking what we've learned from working in this very constrained use case of music, and we're applying it to things like 2D and three-dimensional design, software control, controlling existing games, working in virtual reality. And the efficiencies that we've discovered through working in that constrained case of music is actually proving very useful in those other areas as well, and providing a kind of superior human-computer interaction.
How difficult is it to learn?
So it's actually a very learnable musical instrument because it's largely software, well, it's largely virtual. You can essentially change the rules of your interaction over time. So you can increase the level of responsibility that someone has over the music they're playing over time. Whereas with a beautiful instrument like the violin, one of the issues is you have complete responsibility over every aspect of that sound from when you start, and that usually creates a wall of frustration through which most of us never penetrate. So most of us only spend 30 seconds with a beautiful instrument like the trumpet or the saxophone before we say never again. I'm not going through that experience. So essentially you can give someone an engaging experience throughout the learning process. So there's plenty of opportunity to go from being a novice to a master. You can really see the difference between someone who has a great level of skill, but the process of acquiring that skill is actually much more gradual and much less brutal than it is with conventional instruments.
Thank you.
Thank you.